Hi guys, Mrs. Brumwell here. In this video, I'm going to talk about section 3.3, and we're going to talk about how to find the derivative of inverse functions. So something just to remember, that the definition of inverse functions when they're composed, and I can do this either way, so I could do g of f or f of g. But if f and g are inverses of each other, when we compose them together, it doesn't matter which direction, we get x, okay? Another helpful thing to remember about inverses is that if I have a function f and we have a coordinate x, y, that ordered pair on g just flips around. So y becomes the x coordinate of g and x becomes the y coordinate of g. So the domain and range are flipped, input and output are flipped for inverse functions. This notation is a little bit weird, you guys, but this is how your book does it, so that you can see what it's going to look like for your homework problems. But y naught is just a y value on f of x, and so we usually need to find the x that goes with it. So x naught, y naught is a point on f. Okay. But anyways, if we're trying to find the derivative of g, it is 1 over f prime of x naught if we were finding this at y naught. Okay. And again, this will make a little more sense when we get into an example. So I actually kind of like this statement. This is actually from AP Classroom, but I like this one a little. I think it's a little more clear. But if I have f of a equals b, so I would also know then that g of b equals a, right? Inverse the input-output switch, okay? But f prime of a is our slope, so that's why they use m, right? When I find the derivative at a certain value, I'm getting the slope at that value. Then g of b, g prime of b, so again, b was the output of the original f function. G prime of b is the reciprocal of the derivative, okay? So let's try this out. All right, so we have this function, x to the fifth plus x has an inverse function g. Find g prime of 2. So this 2 is a y value on f, okay? On f. So we need to find g prime of 2 is going to be equal to 1 over f prime of some number. I have to find which x goes with this 2. So how I do that is I'm going to set f equal to 2 because 2 is the y value or the f of x of my original function. So I'm going to set 2 equal to x to the fifth plus x. Now this isn't a super nice one to be able to solve, so I'd actually recommend graphing this. So I'm going to switch over here to Desmos. And basically what I want to do is I want to graph these as 2. So I'm just going to graph y equals 2, and then I'm going to graph y equals x to the fifth plus x. And I'm looking for their intersection. So when y is 2, x is 1. When y is 2, x is 1. Okay? So from that intersection, we got 1, 2. So when y is 2, x is 1. So 1 is what we're going to put in here. Okay, so again, this is the x and the y that go together, that are that point on f of x. So I need to then also find what is f prime of 1. Okay, well, f prime, we're going to find the derivative like I normally do. So f prime of x is going to be 5x to the fourth plus 1. Now I'm going to substitute in 1 for x. Oh, 1. So I've got 5 times 1 to the fourth plus 1. 1 to the fourth is 1 times 5 is 5 plus 1 is 6. So f prime of 1 is 6. So going back to this, g prime of 2 then is 1 over what we got here. I don't know why I wrote f prime there, sorry you guys. F prime of 1 equals 6. Okay, so then f prime of 1 is 6. 6 is what goes here. So this is g prime of 2. All right. Let f and g be functions that are differentiable everywhere. if g is the inverse of f, and g of 1 is 3, and f prime of 3 is -5, what is the value of g prime of 1? Okay, so remember, this means f of 3 equals 1, right? Inverse input-output switch. So 3 is the x that goes with 1 is the y. So g prime of 1 is equal to 1 over f prime of 3, right? The x and the y that go together, okay? All right, and so we're told that f prime of 3 is -5, so I just plug in -5 here. So we get 1 over -5 or -1/5. Okay, the function f is 1-to-1 and has an inverse function. Remember, 1-to-1 just means it passes the horizontal and the vertical line test. And then it has its inverse will be defined everywhere. And so its inverse is g. Find an equation of the tangent line to the graph of g at the point 8, 2. Okay, so 8, 2 is a point on g, so 2, 8 is on f. Okay, so we want g prime of 8 because we want the slope of g, of the tangent line to g, excuse me, we want the slope of the tangent line to g at this point. So I want to know what is g prime of 8. So that's going to be equal to 1 over f prime of 2, because 2 is the x that goes with 8. Okay, so we need to find what is f prime of 2. So f prime of 2, I'm going to kind of do this in one step. So I'm going to take the derivative of f and plug in 2. So this is going to become 3x squared, but I'm plugging in 2 for x, plus 2. Simplify here, let's see, we get 3 times 4 is 12, plus 2 is 16. So when I come back here, this is going to equal 1/16. So that is my slope of the tangent line to g at this point. So now they want the equation of the line, so I'm going to use point slope form. So I'm going to do y minus, our y coordinate is 2, slope of 1/16 times x minus the x coordinate of 8. All right. Okay. Find the derivative of, sorry guys, I realized I just messed up my math there really quick. This one is not 16, it should be 14. 12 plus 2 is 14, so I'm just going to fix the 1 over 16 to be 1 over 14. 14, 14, 14. There we go. All right. Okay, find the derivative of arcsine of x. Okay, so this table already actually gives it to us, you guys, but I want to show you where this comes from before you just start committing them to memory, because I think that'll help it stick a little bit better. Okay, so arcsine is the inverse of sine. So the derivative of arcsine, I'm going to rewrite this. This is another way we see this, right? Sine inverse of x. If I take the sine of both sides, sine and sine inverse would cancel, and we'd be left with x. So we already know the derivative of regular sine, right? So if I differentiate this implicitly, I would get cosine of y dy dx equals 1. Okay? So I would get dy dx is equal to 1 over cosine of y. Okay, so one thing to remember, I'm going to kind of use this equation right here to set up a triangle. So I would like to be able to write this in terms of x instead of y. So what I'm going to do here is I'm going to go back here. So whenever I have sine, or honestly any trig function, the input is an angle, and the output is a ratio. So this is like x over 1. Sine is opposite over hypotenuse. So if y is here, opposite over hypotenuse. Well, I want cosine of y, so I need to find the adjacent over the hypotenuse. So I need to solve for this adjacent side. I'm going to call it b, per the Pythagorean theorem. And I'm going to do x squared plus b squared equals 1 squared. So I get b squared equals 1 minus x squared, so b is equal to the square root of 1 minus x squared. All right, so this side of the triangle is 1 minus x squared. So cosine, so now that's this side. Okay, so cosine's adjacent over hypotenuse. So cosine is going to equal this, so cosine of y is going to equal square root of 1 minus x squared over 1, or just 1 minus x squared. So then when I plug it in here, we get the derivative to be equal to 1 over cosine of y, which is this. So this is why the derivative of arc sine is 1 over 1 square root of 1 minus u squared. Now they put u here because it could be something other than just x in our argument. It could be an expression in there, and then I would use the chain rule after that. Okay, here are the other functions, you guys. They can all be derived similarly. The ones that, if you memorize, I should say you should memorize, are sine, secant, and tangent. The reason you really only need to memorize 3 is because their reciprocals are just the negative of that, okay? So cosine and sine are the same, but cosine's negative. Or sorry, I shouldn't say reciprocal. I should say kind of like partner. So sine and cosine, 1 and negative 1. Cosecant and secant are 1 and negative 1, and tangent, cotangent are 1 and negative 1. Their denominators differ a little bit. Okay, so the ones you memorize are all the positive ones, and then their kind of partner trig function is the negative of that. So you really only have to memorize 3, not all 6. Okay, so we're going to practice using some of these rules and the chain rule. We're still going to be incorporating that to find some derivative functions. Okay, so we're going to find this derivative. So first I'm going to use the derivative of sine inverse, which is the one we just derived. It's this guy. So it's going to be 1 over the square root of 1 minus the argument squared. So it's going to be 4x squared squared times, now the derivative of that inner function is 8x. Okay, so y prime is equal to 8x over square root of 1 minus, that's going to become 16x to the 4th. Okay, all right, this guy, y prime equals, okay, so my outside function is e to the x, so I keep e and I keep that argument the same, sine inverse of x, times the inverse of the derivative of sine inverse. And the derivative of sine inverse is, again, that one we just derived, so it's going to be 1 over 1 minus x squared. And then I can just put that on top of each other, write it as one fraction, so we've got e to the sine inverse of x over square root of 1 minus x squared. All right, C. All right, my outer function is natural log, so it's 1 over its argument, which is tangent inverse of x. And my inner function is tangent inverse. So the derivative of tangent inverse is 1 over 1 plus the argument squared. So 1 over 1 plus my argument's just x in this case. Okay, and again, we can write that as one fraction. So y prime is equal to 1 over tangent inverse of x times 1 plus x squared. All right, tangent inverse of 4x. So this time tangent inverse is the outer function. So it's 1 over, again, I'm using this one here, okay? 1 plus my argument this time is 4x. Okay, and then my inner function being 4x, now I have to multiply by its derivative, which is just 4, using the chain rule. So simplify a little bit, I've got 4 over 1 plus 16x squared. All right, number 5. Okay, so you guys might recognize this. This is the limit definition using g of x. So remember, g of x minus g of c is finding the derivative at a particular value. So another way I can think of this is this right here means find g prime of square root of 3. That's the c value. That's what they want me to find. So I can find the limit, or I can just use my derivative rules. Sorry, that looks funky. Or I can just use my derivative rules to evaluate this. So I want to find g prime. Here's my function. So g prime of x. So arc sine or inverse sine, again, that's the one we derived originally, this guy, okay? My argument this time is x over 2 or 1/2 x. So I've got 1 over the square root of 1 minus x over 2 squared, okay, times the derivative of the inner function, which is just 1/2. Okay, so now I'm going to plug in square root of 3. So g prime of square root of 3 is equal to 1 over, I can put this 2 out front here. So I've got 1 minus square root of 3 over 2 squared. Okay, so here I'm going to get square root of 3 squared, which is 3, and 2 squared is 4. So underneath here I've got 1 minus 3/4, so I'm going to get 1/4 underneath the square root. So I come up here again, so I've got 1 over 2 times the square root of 1/4. Square root of 1/4 is 1/2. And 2 times 1/2 is 1, so 1 over 1 is 1. All right, so the slope of the tangent line at root 3 is 1, which is exactly what that limit definition means. I think that's all for this video. Yep, that was the last one. Thanks for watching, guys.